Welcome, chemistry friends. Today we're diving into the wonderful world of molecules. I'm Devin.
And I'm Frederick. Together we're
Just keep on going.
we're your chemical guides to all things necessary.
And today's star of the show is Phosphorus Pentafluoride.
Also known as the fabulous 5 bonds.
You'll learn what it is used for and why it's such a cool shape and how it behaves in the molecular world. Let's dive in.
Yay!
What is phosphorus pentafluoride?
So, phosphorus pentafluoride. It's colorless gas at room temperature. Scientists use it as a semiconductors, as you can see, catalyst and organic synthesis.
What? Synthesis. But be careful with this stuff. Phosphorus pentafluoride reacts with water to make hydrofluoric acid, which is not great for your health. Handle it with care, folks.
And here's a fun fact about phosphorus pentafluoride. It's one of the only compounds where phosphorus bonds with 5 atoms. Usually it only bonds with 3 or 4. Talk about being an overachiever.
As you can see here, this is the Lewis structure for phosphorus pentafluoride. It's pretty crazy, huh? Alright, let's get technical with phosphorus pentafluoride. It is held together by covalent bonds, which means the phosphorus shares electrons with each 5 fluorine atoms.
Phosphorus brings 5 valence electrons to the party, and each fluorine being 7. That's a total of 40 valence electrons
That's a lot. That's a lot.
to occur for.
Boom!
Let's draw it!
Oh, we draw it already. Boom. 5 single bonds between phosphorus and fluorine. Simple and elegant. Just like
us.
one of
Elegant.
us.
Both of us.
No.
Now, let's talk about VSEPR, or also known as valence shell electrons pair repulsion theory. It's a fancy way of saying that electron pairs want to stay as far apart as possible.
That's why what's his name?
Phosphorus pentafluoride.
Phosphorus pentafluoride has a trigonal bipyramidal shape. 3 fluorines form a flat triangle around the middle. As you can see, a flat triangle around the middle. And the other 2 stick out from below and above. Like just exactly like a sandwich, but you can't eat this because it's gas.
And don't forget bonds 120. 120.
Yes.
No, 120.
Yes.
And triangles 90 degree. Between top and bottom bonds.
Oh.
Geometry has been fun.
All right, let's talk about polarity. Each phosphorus and fluorine bond is polar because fluorine is way more electronegative than phosphorus. But
because the molecule is symmetrical, all those dipoles cancels out. That makes phosphorus pentafluoride nonpolar overall.
oh, my legs. Okay.
Since It's a non-polar phosphorus pentafluoride. Only has London dispersion forces. The weakest of all intermolecular forces. That's why it's a gas at room temperature.
Exactly. Compare that to water, which has hydrogen bonding, way stronger forces, so it is a liquid. Intermolecular forces make all the difference. Yes, they do.
Now let's wrap it up. Physical properties. Pentafluoride is a gas at room temperature with a boiling point of negative 484.5 Celsius.
I'm freezing. Whoa, it's cold.
Pretty chilly.
Yeah, it is. And it's super reactive with water, breaking down into hydrofluoric acid. That's why it's usually stored carefully in dry conditions. We hold it together now.
Remember, kids, just because it's colorless doesn't mean it's harmless.
Oh, let me get a mask. You want one?
No.
You're gonna die.
Oh, I should.
And that's why everything you need to know about phosphorus pentafluoride.
We cover it uses bonding, shapes, polarity, and even physical properties. If you didn't know phosphorus, you sure do now. He just died.
Watching, and don't forget to stay curious and exploring about the world of chemistry.
Yep.
And always wear your mask around dangerous gases, because you can die just like we did. Yep.